Good morning, this is Mr. Precella. We're about to finish up this review sheet for the Math 373 final quiz in my blended college algebra class. We're going to look at a word problem here. A basketball player scored 36 times during one game. He scored a total of 57 points. He got 2 points for each 2-point shot and 1 for each free throw. How many 2-point shots did he make, and how many free throws did he make? So, what are my unknowns? I think the questions tell us our unknowns.
How many 2-point shots?
Okay, how many 2-point shots did he make, and how many free throws did he make? So there were 2-point shots. I like to summarize my information in a table. And this column here will be the quantity, or the number of shots. He made X 2-point shots and Y 3 free throws. Why do I want to call them 3-point shots? They're free throws. And they told us that obviously each 2-point shot is worth 2 points, and each free throw was worth only 1 point. And they gave us some totals. They told us that this player scored 36 times during one game. So if we total the number of throws that he made, that should equal 36. Now, they also told us that he scored 57 points. So if we total up all the points he made, we would get, did I say 56? It's 57. 57, you're right. It's 57 points that he scored. We have two variables. So if we're going to have a unique solution, we need two unique equations. So I'll get us started. We can total, if we take the number of 2-point throws plus the number of free throws and add them up, that should give us the total number of throws he made, 36. He scored 36 times during the game. Now the value equation involving points. He made X 2-point throws. Each 2-point shot was worth 2 points, so he scored a total of 2x points from those 2-point throws. How many points did he score total from his Y free throws? 1 point per shot times the number of shots. 1 times Y gives you Y. Here are all the points he made from the 2-point throws. Here are all the points he made from the free throws. If you add those together, it better give us 57. So there's my system of equations. What do y'all want to use, elimination or substitution? We saw Kramer's rule in this course as well, but I think I'll just use elimination or substitution. Which one do you want to use? I'll let you choose. Elimination. Let's eliminate the y's. Notice the y's already have the same coefficient, but not the same sign. I think we have 1 and 1. I think I'm going to make this top one a -1. I'm going to make that top one a -1y. Distributing the -1 across that top equation, we get -x, keep going, minus y is equal to -36. The second equation stays as is. Add the two equations together, and what are we going to get? Combining the x terms, we get negative 1x plus 2x, I agree, is just an x. Adding the y terms together,
Cross those out.
yeah, they canceled out. We eliminated them. Equals, adding the constants, negative 36 plus 57. Does that give us 21? So what was x? The 2-point throws. So this player made 21 2-point throws. How do we find the number of free throws?
Plug in 21.
Okay, I think I'll plug the 21 into that first equation. X plus y equals 36. Plugging in 21. 21 plus y equals 36. So y has to equal, y equals 15. So we knew x was 21, y had to be 15. So this star basketball player made 21 2-point throws and 15 free throws. Any questions there? Okay. Hey, we have another word problem. Number 12. I'm going to get it ready there. A woman bought some large, this is the one involving those frames. We decided those were picture frames, right? A woman bought some large picture frames for $18 each and some small frames for $7 each at a huge closeout sale. If she bought 21 frames for a total of $224, find how many of each type she bought. Okay, well, what are the unknowns?
How many large and small frames?
Okay, so the number of large frames and the number of small frames. I'm going to summarize using a table again. Large frames and small frames. And the first little column I'll write there will be the number purchased. I guess I should have written quantity, that's shorter. And I'll use the same variables I was using earlier, just X and Y. She bought X large frames and Y small frames. They also told us the price of these frames. She told us that the large frames cost $18 and the small frames cost $7. So I'll say cost per frame. Maybe this woman owns a gallery. That would explain why she's buying all these picture frames. Okay, so she spent $18 on each large frame and $7 on each small frame. They told us that she bought 21 frames total. Where do you think I'll put that on my table?
Under the what?
Okay, right here. If you total up the number purchased, we should get 21. She bought 21 frames. She spent a total of $224. Where do you think I'll put that?
Under the 7.
Okay, right there. Totaling up all the costs, it's $224. So, once again, we have two variables, so we want two unique equations to be able to find a unique solution. If we take the number of large frames plus the number of small frames, that had better equal 21, I agree. We need another equation. How about that value equation? How much money did she spend on the X large frames? $18 per frame for a total of cost per frame times the number of frame, 18x. That's all the money she spent buying those large frames. How much money did she spend buying the small frames? $7 per frame times the number of frames. So $18X were spent buying large frames. $7Y were spent buying the small frames. Added together, that had better give me
224.
224, I agree. And hopefully you have your calculator ready. Unfortunately, I don't have mine. So I think we'll use elimination again. I prefer elimination over substitution. What do you think I'm going to eliminate, the X or the Y? What do you think I'll eliminate, X or Y? I think I'll eliminate Y. Why? Because that number's smaller, 7 smaller than 18. I'm going to have to multiply up here. I have a positive 7Y. What do I need here in order to eliminate the Y's? A negative 7, so I'll multiply by negative 7. That's going to give me, the first equation's going to become a negative 7x. What else? Negative 7x.
Negative 7y.
Okay, equals negative 7 times 21. Is that negative 147? We still have that bottom equation, 18x plus 7y equals 224. Add the two equations together. That gives us negative 7x plus 18x, 11x, I agree. Adding the y's, what happens? So we just eliminated those. Negative 147 plus 224. That's going to give me a, what is it? 77. I agree with 77. Oh, dividing by 11. How many large frames did you buy?
7.
She bought 7 large frames. Let's do the substituting in just mentally. We know that x is 7. What does y have to be to give us 21? 7 plus what gives us 21? 14. So y is 14. So this gallery owner bought 7 large frames and 14 small frames. Any questions there? Oh, number 14. No, number 13. Number 13. Solve the equation analytically. Look at this. The variable is up in the exponent. What do you call an equation where the variable is up in the exponent?
A logarithm?
No. It starts with an E. An equation that has a variable in the exponent is said to be a blank equation. Maybe an exponential equation. That was I guess it was an obvious answer, so you weren't seeing it because the variable's in the exponent. We say that it's an exponential equation. Okay, we have a base of 2 on the left side. 2 is a prime number you're not going to change to. So if we're going to use the same base method, we better be able to use a 2 on the right side. 2 to what power will give us 16? 2 to the 4th power, I agree. Then once we have the same base on both sides, what can we do? Drop them, set the exponents equal. Add 5 to get 2x equals. Here.
-1 or 9.
9. 4 plus 5 gives me 9. And then to give me x equals 9/2. Any questions there? We were just tested over that stuff. Weren't we on test 2? I mean test 3, pardon me, not test 2, test 3. The most basic method of solving an exponential equation. You get a common base on both sides. Once you have the same base on both sides, drop the base, set the exponents equal. Now we're going back to some graphing. For the equation y equals x squared, create a table with at least 3 ordered pairs that are solutions to the equation, and then graph the equation. Now remember, when we were graphing these things in the homework, we had to use that little graphing tool, but since I'm doing it on paper, I can't use the graphing tool. I have to draw the little graph by hand on paper, just like y'all are doing. Okay. Excuse me. First thing we do, plug in -2 for x. Y'all see the equation is y equals x squared. Plugging in -2, what are we going to get for y?
4.
-2 times -2, I agree with +4. Plugging in 0, what are we going to get for y?
0.
0. Plugging in +2, what are we going to get for y?
4.
I agree. And now we'll come over here, plotting our points. -2, 4, that says left 2, up 4. And then 0, 0. And finally 2, 4. I think we can see that this is a parabola. That x squared says it's going to be a smooth U-shaped figure. In this case, it's opening upward like that. Any questions there? And then this assignment for this problem came from, we were using a 3-point quadratic tool. That's why they had us finding 3 points. Then you just click the tool and plot the points. Okay. One more. Oh, y equals x cubed minus 2. This isn't going to be a parabola. That exponent is a 3. So I'd call this a cubic. Y equals x cubed minus 2. And notice they're giving us 4 points, 4 x values. They want us to find 4 points. There's a 4-point cubic tool that we'd use here and to graph the thing. So here we go. Plugging in -1. X is -1. We get y equals -1 cubed minus 2. -1 cubed is -1 minus 2 gives me a y value of,
1.
be careful, that's a -3. Plugging in 0. Plugging in 0, we get y equals 0 cubed minus 2. What's that going to give me for y? -2. I agree. What's the next number we have to plug in? 1. That gives me a 1 cubed minus 2. 1 cubed is 1 minus 2 gives me a y value of -1. I agree. One more number to plug in. I'll do it right here. We're plugging in what? 2. So we have y equals 2 cubed minus 2. 2 cubed is 8 minus 2 gives me a y value of 6. And y'all see the 4 ordered pairs we have? We have our 4 ordered pairs. Let's see. I'll use this. Okay, so the first one, -1, -3, left 1, down 3, then 0, -2, so left, right, 0, down 2. Oh, goodness, those units are close, aren't they? And then 1, -1. So right 1, down 1. And at this point, it looks like it's a line, doesn't it? But once we get to 2, right 2, up 6. It's going to start becoming very steep. That linear pattern ends. And we get a graph that looks like that. Sort of a squiggly. Any questions there? Once again, when you're graphing these on My Math Lab, you'll need to use, this is the 4-point cubic tool. So you use the 4-point cubic tool on number 15, and on number 14 they have a 3-point quadratic tool. Any questions there? There was number 15, the last one. Well, okay, we got through that whole review sheet, so I think I'm going to take a little break now. Bye-bye.